Deriving the differential equation of the geodesics solution. Let the t be a unit tangent to the geodesics at any point so that t equals to dr ds equals to r dash, which implies r double dash equals to dr dash over ds equals to t dash, which implies r double dash equals to t dash, but t dash equals to kn be the Surratt-Frenet formula. So r double dash equals to kn, equation 1. Since r equals to uv, so r dash equals to del r over del u into del u over del s plus del r over del v into del v over del s, which implies r dash equals to r1 u dash plus r2 v dash. Differentiating with respect to s, we get r double dash equals to r1 u double dash plus dr over ds into u dash plus r2 v double dash plus dr2 over ds into v dash equals to r1 u double dash del r1 over del u into del u over del s plus del r1 over del v into del v over del s into u dash plus r2 v double dash plus del r2 over del u into del u over del s plus del r2 over del v into del v over del s into v dash equals to r1 u double dash plus r11 u dash plus r12 v dash into u dash plus r2 v double dash plus r12 u dash plus r22 v dash into v dash equals to r1 u dash u double dash plus r11 u dash square plus r12 u dash v dash plus r2 v double dash r12 u dash v dash plus r22 v dash square equals to r double dash equals to r1 u double dash plus r2 v double dash plus r11 u dash square plus 2 r12 u dash v dash plus r22 v dash square. Equation 2. Putting the values of the r double dash from 2 in equation 1, we get r1 u double dash plus r2 v double dash plus r11 u dash square plus 2 r12 u dash v dash plus r22 v dash square equals to kn. Equation 3. Taking the dot product of each of the sides of the tree with respect to r1 and r2 respectively, we get r1 square u double dash plus r1 dot r2 v double dash plus r11 dot r1 u dash square plus 2 r12 dot r1 u dash v dash plus r22 dot r1 v dash square plus equals to r1 dot kn, which implies r1 square u double dash plus r1 dot r2 v double dash plus r11 dot r1 u dash square plus 2 r12 dot r u dash v dash plus r22 dot r1 v dash square equals to 0. Equation 4. r1 dot n equals to 0 and dr1 dot r2 u double dash plus r square v double dash plus r11 dot r2 u dash square plus r12 dot r2 u dash v dash plus r22 dot r2 v dash square equals to r2 kn, which implies r1 dot r2 u double dash plus r2 square v double dash plus r11 dot r2 u dash square plus r12 dot r2 u dash v dash plus r22 dot r2 v dash square equals to 0. Equation 5, because r2 dot n equals to 0, but we know that E equals to r1 square, f equals to r1 r2, and g equals to r2 square, and E equals to 2r1 dot r11, which implies r1 dot r11 equals to 1 upon 2 e1, e2 equals to 2 r1 dot r12, which implies r1 dot r12 equals to 1 upon 2 e2, f equals to r11 dot r2 plus r1 dot r12, which implies r1 r2 dot r11 equals to f1 minus r1 dot r12 equals to f minus 1 upon 2 e2, f2 equals to r12 dot r2 plus r1 dot r22, which implies r1 dot r2 equals to f2 minus r2 dot r12 equals to f2 minus 1 upon 2 g1 equals to 2 r2 dot r12, which implies r2 dot r12 equals to 1 upon 2 g1, g2 equals to 2 r2 dot r22, which implies r2 equal dot r22 equals to 1 upon 2 g2. Putting these values in 4 and 5, we get EU double dash equals to f v double dash plus half e1 u dash square plus 2 into 1 upon 2 e2 into u dash v dash plus f2 minus 1 upon 2 g1 into v dash square equals to 0, which implies E u double dash plus f v double dash plus 1 upon 2 e1 u dash square plus e2 u dash v dash square plus f2 minus 1 upon 2 g1 into v dash square equals to 0. Equation 6, and f u double dash plus g v double dash plus f1 minus 1 upon 2 e2 into u dash square plus 2 into 1 upon 2 g1 into u dash v dash plus 1 upon 2 g v dash square equals to 0, which implies f u double dash plus g v double dash plus f1 minus 1 upon 2 e2 u dash square plus g1 u dash v dash plus 1 upon 2 g v dash square equals to 0. Equation 7, thus we have eu double dash plus f v double dash plus 1 upon 2 e u dash square plus e2 u dash v dash plus f2 minus 1 upon 2 g1 v dash square equals to 0, and f u double dash plus g v double dash plus f1 minus 1 upon 2 e2 into u dash square plus g u g1 u dash v dash plus 1 upon 2 g2 v dash square equals to 0. These are the general differential equations of the geodesics on the surface. They are clearly equivalent to the equations d over ds of eu dash plus fv dash equals to 1 upon 2 e1 u dash square plus 2 f1 u dash v dash plus g1 v dash square d over ds of fu dash plus g v dash equals to 1 upon 2 e2 u dash square plus 2 f2 u dash v dash plus g2 v dash square. Another form of the differential equation of the geodesics is obtained by solving the equation 6 and 7 for u double dash and v double dash, that is u double dash equals to minus l u dash square plus m u dash v dash plus n v dash square. Equation 8, and v double dash equals to minus lambda u dash square plus 2 mu u dash v dash plus nu v dash square. Equation 9, where L equals to 1 upon 2 h square g e1 minus 2 f f1 plus f e2, m equals to 2 upon h square g e2 minus f g1, n equals to 1 upon 2 h square into 2 g f2 minus g h1 g1 minus f g2. Lambda equals to 1 upon 2 h square into 2 e f1 minus e e2 minus f e1. Mu equals to 1 upon 2 h square into e g1 f minus e g1 minus f e2, and nu equals to 1 upon 2 h square e g square minus 2 f f2 plus f g1. A curve on the surface is however determined by the single relationship between the parameters. Hence, we can combine the equation 8 and 9 in a single equation, since we have dv over du equals to dv over ds over du over ds or v dash over u dash. Therefore, d square over v over du square equals to u dash v double dash minus v dash into u double dash upon u dash square. Equation 10, multiplying the 9 by u dash and 8 by v dash, so subtracting we get u dash v dash minus u dash v double dash minus v dash u double dash plus u dash square into lambda u dash minus l v dash plus 2 u dash v dash into mu u dash minus m v dash plus 2 v dash square into v u dash minus m v dash equals to 0. Equation 1, we are using 10. Equation 11 becomes d square v over du square equals to n d v over du whole cube minus 2m minus nu into dv over du whole square plus l minus 2 mu dv over du minus lambda. Equation 12.